Thank you for joining me. I'm glad you are there. Let's solve what we have on the board. But before that, please hit the like button and subscribe to this channel so that you have access to subsequent videos. Now back to what we have on the board. We have circuit diagram of resistors in parallel and in series. So looking at this, we have two resistors in parallel, resistor X and resistor 2 ohm. Then connected to a 2 ohm resistor. Now from this question they said, study the circuit diagram and from it calculate the value of X, given that the ammeter reading is 2.5 ampere. So once we have a circuit like this, the first question we'll ask ourselves is how to resolve both the ones in series and the one in parallel. So solution. Now we have the ammeter reading. Of course, the ammeter reading is the current flowing through the circuit. Current flowing through the circuit is 2.5 ampere. Now the voltage or potential difference, which is V, flowing in the entire circuit is 8 volts. Now remember, from Ohm's law, we have that V is equal to IR. Now if we make R the subject, we have R will give us V over R. Now this R here is the total resistor flowing in the circuit. Now from here, since we have V, I will have I. Let us first get the total resistor in the circuit, which will give us V is 8 while I is 2.5. Now if we divide 2.5, 8 by 2.5, we are going to have 3.2 ohms via calculation. Now we have that, recall that total resistor is equal to resistors in series plus resistors in parallel. And we have gotten this, of course, it is this. The resistor, just this one alone is in series, while this one is in parallel. So let us resolve this and add it to this. So we have total resistors in parallel will give us 1 over R. Of course, if we have P here, means resistors in parallel will give us 1 over R is equal to 1 over R1 plus 1 over R2, which will give us 1 over R in parallel will give us 1 over, of course the first one there is X plus 1 over 2. So which will give us 1 over R in parallel. LCM of 2 and X will give us 2X. Okay, 2, we'll have X divided by 2, it will give us 2. 2 times 1, 2. Plus 2 divided 2x, it will give us x. Now x times 1 will give us x. Therefore, we have 1 over R parallel is equal to 2x, 2 plus 1. Now we are looking for the resistors in parallel and not inverse. So because we are looking for it, it's either we cross multiply or we invert. If we invert this, R parallel will give us 2x all over 2 plus 1 ohm. So this is our resistor in parallel. We now have that we have resistors, total resistor is R in series plus R in parallel. So we can now bring in these values. Total resistor which flow in the circuit from the two variables is 3.2. So 3.2 is equal to resistor in series 2 plus resistors in parallel. Of course, resistors in parallel is 2x all over 2 plus sorry. So that is x here, please. That is x here. 2 plus x. Okay. 2 plus x here. So this is 2 plus x here. So if we now add this, we have, because these are like terms, we collect like terms. 3.2 minus 2 will give us 2x all over 2 plus x. 2 plus x. Now we have 3.2 minus 2 gives us 1.2 is equal to 2x all over 2 plus x. At this point, we can cross multiply at this point. So if we cross multiply, we have 2x is equal to 1.2 into 2 plus x. Now we have 2x is equal to 1.2 multiplied by 2. Of course, it will give us 2.4 plus 1.2 multiplied by x will give us 1.2x. At this point, we observe that these and these are like terms, so we collect like terms. So collect like terms to now give us 2x minus 1.2 is equal to 2.4. Now 2x minus 1.2x will give us, from calculation, it will give us 0.8x equal 2.4. Now we're looking for x, make x the subject. X will give us 2.4 all over 0.8. And if we do that division, we are going to get 3 ohms as our answer. And of course, it corresponds to option D. Okay, we'll take the next one. Now we have the second question. Calculate the value of R given this diagram. And of course, this is a series connection where the same voltage flows and the same current is flowing, apart from this one here. Okay, so this one is in parallel, this one is in series. We have our current and we have our voltage. Solution. Just like we solved the other time, since I here is 2 ampere, V is 12 volts. Now we have from Ohm's law that R is equal to V all over I, which will give us 12 over 2 will give us 6 ohms. Now, having gotten that, we resolve the one in parallel. If we resolve the one in parallel, we have 1 over R parallel is equal to 1 over R1 plus 1 over R2. So 1 over R in parallel will give us 1 over, and of course this one is R plus 1 over 6, which will give us the LCM of R and 6 is 6R. Now R divide 6R will give us 6. 6 times 1, 6 plus 6 divide this will give us R. R times 1 is R. So we'll now have that our total resistors in parallel will give us, because of this, we invert, this means inversion. Therefore, we invert this one will come down. We now have 6R all over 6 plus R. Okay, so we have, recall that we said earlier that resistors in, total resistors will give us that in series plus that in parallel. So total resistor is this, and of course this is total resistor flowing in the circuit. 6 ohms is equal to the one of series 3 plus the one of parallel, which is 6R all over 6 plus R, as usual. So, sorry, this is 6 here. As usual, collect like times. 3 will come over, it becomes this 6R all over 6 plus R. 3 minus 6 minus 3 will give us 3 equals 6R all over 6 plus R. We can cross multiply at this point. We now have 6R is equal to 3 into 6 plus R. And we'll have 3 times 6 will give us 18 plus 3 times R, 3R. These are like terms. Send this one back here. It will, the sign will change to minus. 3R is equal to 18. Now 6R minus 3R will give us 3R equals 18. Therefore, R will give us 18 over 3. R is equal to 6 ohms. Option B. Okay. Thank you very much. This is where we draw the lesson to an end. Please do not forget to share this video with your friends. Thank you very much.